Hello students, welcome in the series of lectures on multiple integral. In the previous lecture, we have done discussion that how one can find the limit of an integral from a given region. Continuing the same, in this lecture, we will also discuss some more variety of problem in which a reason of integration is given for finding the limit of integration. So now without delaying, let us start. I'm just taking first question. Basically, what is the difference in the question that we have did earlier and the question that we are going to solve today? The basic difference is that if one elementary reason or strip is not sufficient for finding the limit of a function, limit of an integral from the reason, then what should we do? In such case, more than one elementary strips are required. Let us see how we can take more than one strip. The first thing is that when we rotating the strip inside the region, its starting and ending point should not be changed inside the region. If it is changing, if it is changing, it means another strip is required. Let us take an example. Suppose that I am having an integral like double integral over r f of xy, that is function of xy dx dy, where r is given as a region bounded by the points 0 1 1 0 and 1 comma 2. Here the region is given by the region is what, the bounded by the point 0 1 1 0 and 1 comma 2, means the curves are not given, points are given. So we should draw the point and try to identify the region firstly. Let us see. So the points are 0 1. 0 1 is a point on y-axis, like somewhat over here. 1 0 is on x-axis, somewhat over here. 1 comma 2, that on x-axis we are having 1 and on y-axis we are having 2. Suppose that this is a point 0 comma 2. So somewhere here the point 1 comma 2 will lies. On x-axis 1 unit distance, on y-axis 2 unit distance. Just match these points. I just match these points. If I naming the points, let it be A, B, C. So A, B, C is the required region of integration from which we need to find the limit of integral. As we can see, the equation of this line is what, x equal to 1. Moreover, we need to find the equation of line AC and AB because they will be used when we are finding the limit. Now, how to find the equation of line AC? I hope you remember that we can find the equation of a line passing through two given points. So we can apply the points are 1 comma 2 and 0 comma 1. So just apply the formula and what we will get? The equation of a line AC and then the equation of the line AB. I'm directly writing them. It is y equals to x plus 1 and this one is y equals to 1 minus x. Simply the formula I think you remember. It's y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. Just use this formula to find the equation of line AC and AB because they will be used in the region. So by using these formulas, I will obtain the equation of the lines y equals to x plus 1 for AC and y equals to 1 minus x for AB. And this is the required reason of integration. Now just try to understand, students. If I am taking a strip parallel to y-axis, not y-axis, x-axis. If I am taking the strip parallel to x-axis, suppose the strip is taken over here. parallel to x-axis. You can see the end point of the strip is started from the starting of the strip is what? Line AB, and terminated is line BC. On the same time, if I am rotating this strip inside the region, so after this perpendicular line, means when the strip is entered above this line, like somewhat over here, you can see now the starting point of the strip will change. Starting curve of the strip will change, and now it is starting point is this much, this curve, terminating is same. So in these kind of problem, we need more than one strip, because the rotation of the strip when we are doing inside the string, inside the region, starting point is changed after this, if let this point is D, after the line AD, which is the perpendicular on the line BC. So one strip is not sufficient for this reason. So we have to take two strips. It means the integral should divide it into two parts. One is A, B, D, another is A, D, C. And both the different limit we should put on it. Let us see. I'm firstly writing the limits. Firstly, I'm writing the limits for the region. This region, what is the name of this region? A, B, D, and B. For the region ADB. Limit of x is started on the curve. And what is the value on this curve? X value, y equal to 1 minus x. So x will be how much? 1 minus y. So x equals to 1 minus y2. Terminated on this curve, what is the value of x over here? 1. So x equal to 1 minus y2, x equal to 1. Now for this reason, means ABD, the variation of y-axis is this much only. Means we can say from the point O to the point A. This is the variation of y-axis for this reason. It started from the center, that is the value of y over here is 0, terminated on the point A. The value of y on the point A is what? 1. So the limit of y will be what? Y equals to 0 to y equal to 1. So the limit for this reason A, B, D is x equal to 1 minus y to x equal to 1 and y equal to 0 to y equal to 1. Moreover, it's not the reason is completed because almost half part we have done. The next part is A, C, D. If I am talking about the reason A, C, D, once again, now the strip is started on the curve y equals to x plus 1. A strip is started on the curve y equals to x plus 1. So we need to find the value of which variable, x or y? X, because we are taking a strip parallel to x-axis. So the value of x will be how much? Y minus 1, 2. On this curve, the value of x is the same, x equal to 1. Moreover, the variation of y-axis is this much. This is the variation of y-axis from the point A to the point this. If I just make this point A, B, C, D, E, so the variation will be A to E. What is the value of y on the point A? It's 1. At the point E, it's 2. So the value of y or the limit of y will be y equal to 1 to y equal to 2. So now the integral, which is double integral over R f of xy dx dy, for which the reason of integration is given by this much, we are having this set of limit. Now the question arises that which limit should be put on the integral, because we are having two set of limit, one for the reason ABD, another for the reason ADC. The answer for this question, student, we should put both the limits. Let us see how. That is the given integral, which is like integral over R f of x comma y dx dy. I'm just dividing the whole integral into two regions. The one reason, if you see, the total reason is ABC. I'm firstly writing the total reason ABC, f of x comma y dx dy. Now break it according to the strip that I taken. So ABD and ACD means it will be equals to integral on ABD f of x comma y dx dy plus double integral over what the second one, a d c f of x comma y dx dy. By using a property of definite integral, that integral can be breaked. So I just break according to the reason. Now put the limits. For the reason ABD, limit x equal to 1 minus y to 1, x equal to 1 minus y to x equal to 1, and y equal to 0 to y equal to 1, f of xy into what? Dx dy plus the second one, ADC, the limit of x is from y minus 1 to 1. That is, the limit of x equals to y minus 1 to x equal to 1, and y is what? From 1 to y equal to 2. Inside we are having f of xy dx dy. Now just do the integral. If we are having f of xy is given, we can solve the integral in the reverse order, and whatever comes, that will be the value of the given integral. So now I think you can understand that why we needed two strips. Because when we rotating the strip inside the region, its starting point is changing after the line AD. On the same time, you can say, sir, why we are taking a strip parallel to x-axis? We can take parallel to y-axis. No doubt, we can take parallel to y-axis also. And when we are taking parallel to y-axis, only one strip is needed. Let us see how. The same question I am solving again. If we are taking the strip parallel to y-axis. For x-axis, we needed two strips, but for y-axis, let us see what will happen. So once again, I am drawing the region. This is the point 0, 1. Over here, we are having 1, 0. Somewhat over here, we are having 1, 2. And if I join these points like this is the required region that I am getting. Now, if you know the name of the curve, we are having the name of the curve as y equals to x plus 1 and y equals to x minus 1. This is the curve. Its name is what? Y is equals to 1 plus x. And this is the curve whose name is y equals to 1 minus x. Let us check. Now, y equals to x plus 1, the first one is, and the second one is x, y equal to 1 minus x. Y equal to 1 minus x. So y equal to x plus 1 and y equals to 1 minus x. That. Now I am taking a strip parallel to y-axis. All of you just pay attention for it like this. Now you can see, students, if I am rotating this strip along x-axis, you can see its starting will always be this curve and terminating will always be this curve. Means starting and terminating is not changing. Starting and terminating is not changing. So only one strip is needed for it. And what will be the limit in this case? Starting from this line. So the value of y on the lower curve is 1 minus x to upper curve 1 plus x. The limit of y will be y is equals to 1 minus x to 1 plus x. Now, what about the x-axis variation? You can see the variation for x-axis, if this point is O, this point is A, OA. The variation of x-axis what is? O to A. At the point O, the value of x is what? 0. And at the point A, the value of x is what? 1. So the same question can be solved by this manner also if we are taking a strip parallel to y-axis, and this will be the limit. Moreover, in this case, the order of the integral will be what? Dy dx. It means the integral that is given to us, double integral over r f of x comma y dx dy will be equals to double integral. The limit is y equals to 1 minus x to y equals to 1 plus x, and x equals to 0 to x equal to 1. Inside the function of xy into dy dx. Remember this thing, dy dx, because the order of the integral is now y to x. Y to x means firstly for y, then for x. So now you can say, sir, since if the integral can be solved by taking only one strip, why we are taking two strips? The answer for this question is that, students, when we are dealing with the change of order of the integration, means the next topic, when we are dealing with the change of order of the integration, in that case, it is not necessary that if the original question is taken strip parallel to x-axis, we should take parallel to y-axis for changing the order. If original question is taking parallel to y-axis, we should take parallel to x-axis. Means what? Overall, that we should know both the ways, how to take strip parallel to x-axis, how to take strip parallel to y-axis. But suppose that the same question is given to you, means not in change of order, then you should prefer to take a strip parallel to y-axis, not parallel to x-axis, not parallel to x-axis. I hope you understood the concept that why I'm taking two strips. Sometime it is also that in place of two, we need to take three strip, four strip. That is the extension of one strips we are having. To make it more clear, I am taking one more example, and this time the question is, it is given that our integral, we are having an integral r f of x comma y dx dy, and the region of integral is given bounded by the point 0 0, 1 comma 1, 1 comma 5. The points are given what? 0 0, 1 1, 1 comma 5, or yeah, 0 0, 1 1, 1 comma 5. These are the point given to us, and we need to find the limit of integration. Let us see. So firstly, in order to identify the region, we should draw the points. 0 0, that is like this much. 1 1, if suppose that this distance is 1, this distance is 1, somewhere here we will get the point 1 comma 1. 1 comma 5, that is on x-axis we are having 1, on y-axis we are having 5. So suppose that this is the point 0 comma 5. So somewhere here we will get the point 1 comma 5. Join these points. So if I join these points, this is what the reason that I will get. So this is what, if I just join these lines also like this. So this is the line from, yeah, if I match these things, the reason is what? O, A, B. The reason for the problem is what? OAB. Now, once again, you can see, students, I am just shading the reason so that it's easy to identify. Now we need to decide, yeah, just give me one question's answer, that if I'm taking a strip parallel to y-axis, should I take one strip or two strip? Think on it. What I'm saying, if I take a strip parallel to y-axis in this question, should I take one strip or two strip? I hope you got your answer. The answer for it is only one strip is needed. Only one strip is needed because the variation of the strip inside the region, because the variation of the strip inside the region didn't change its starting and end curve. Starting will be always this curve and terminated will be always this curve. Now, I'm not going to take parallel to y-axis. You can take it by yourself. Now I'm taking parallel to x-axis. So for parallel to x-axis, I should draw like this, a straight perpendicular on the line OB, and the strip will be, one strip will be look like this. One strip will be look like this. Another strip will be look like this. So we should take two strips, and this is how the strip will look like. So now let us find limits for it. Parallel to y-axis, only one strip is needed. Parallel to x-axis, we should take two strips. So let this point is A, B, C. This point is C. So I should find this point is 1, 1. So this will be what? 0, 1. And this is 1, 5. So this will be 0, 5. Yeah. So now I'm writing the limit for the region OAC. Limits for the region OAC. For that, I need the equation of the line 1, 5, equation of the line which is passes through 1, 5 and 0, 0. 1, 5 and 0, 0. Let us find the equation. We are having that y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. So y1 will be 0, y2 will be what? 5 minus 0 upon x2 is 5 minus 0 into x minus 0. So y is equals to 5x. The equation that I'm getting for this curve is what? Y equal to 5x. So this will be what? The name of this curve is y equals to 5x. In this question, starting is same, but terminated is difference. Now what is the equation of OA? Passing through 0, 0, 1, 1. The name will be y equal to x, and this name will be what? X equal to 1. The strip is started on this curve. What is the value of x over here? Y upon 5. X equals to y upon 5 to here. What is the value of x? It's y. So limit of x is y upon 5 to y. What about the limit of y? Let us see. The variation of y-axis is this much only. Means 0, 0 to 0, 1. At 0, 0, the value of y is 0. At 1, 0, 0, 1, the value of y is 1. So the limit for the lower region is what? X equals to y upon 5 to y and y equal to 0 to 1. Moving to the second region, that is region A, B, C. So what will be the limit for this region ABC? It will be once again started on the same curve. So x equals to y upon 5, 2. Terminated on the curve x equal to 1. So x equal to 1. Then the variation on y-axis will be what? This much. That is from the point C to the point this much. A, B, C, D. Let it be D. Here y is 1. Here y is 5. The limit will be y equal to 1 to y equal to 5. So these are the limits that we obtained, students. Now put it in the integral. Order of the integral will be what? In both the cases dx, dy. Because we are taking strip parallel to x-axis, it means the integral which we are solving over R will be break in two integral if we are taking a strip parallel to y-axis. That is, one is for the region OAC. OAC, f of x comma y dx dy, plus the second one will be what? Region ABC, ABC, f of x comma y dx dy. Now put the limit over here. So if I am putting the limit of OAC, so the limit of OAC is what? X equal to y upon 5 to y, and y is equal to 0 to 1. Inside we are having f of x comma y dx dy, plus the second integral. For the second we are having y upon 5 to 1, x equals to y upon 5 to 1, and y equals to 1 to 5 inside f of x comma y dx dy, x comma y dx dy. Now this will be the limit of the integral from the given region. Now I just also suggest you try to take the limit parallel to y-axis in the region like this and check whether you are getting the limits or not. So student, I hope you understood the concept. This is how we can find the limit of integration from the given region. I hope you understood the concept. And that's all from my side for this lecture, students. In the next lecture, we will learn how we will change the order of the integral. How we will change the order of the integral. So thank you. Thank you very much for your attention.